So here's the example on finding matrix inverses. Here was the slide where I just gave you the formula. And again, this is one place where I'm just going to ask you to memorize the formula. So before we do the example, let's just again point out some things about what we see here in this formula. So we have a square matrix 2 by 2. Again, inverses only can be done for square matrices. I'm going to ask you to memorize the formula just for 2 by 2s here. And 3 by 3 and bigger, we're just going to do on the calculator. But so the formula for a 2 by 2 inverse is if I have my A matrix A here, it's A, B, C, D. The way I'm going to find the inverse is I'm going to take this scalar, which is the reciprocal of 1 over the determinant, and multiply it by this jumbled up matrix, which looks to be, and then we talked about this in class, what I do is I switch the numbers on the diagonal. So D is going to go that way, and A is going to come back this way. That's what we have there. And then the C and B are going to stay in the same spot, but we're just going to go ahead and change the signs. And again, this 1 over A here, this A with the bars, that means take the determinant of A, and we're going to take the reciprocal of the determinant. And recall that this is not going to exist when, or the matrix inverse won't exist when the determinant of A equals 0, because we can't take 1 over a 0 number. So that'd be the one. Well, if it's not square, we can't find an inverse. And then if it is squared, we're not going to be able to find an inverse if the determinant is 0. So let's move on to the example. So we want to find the inverse of this guy here, 5, 4, 2, 3. Well, I would say the best first step in this is to just find the determinant, because if the determinant is 0, we're done because we can't actually find the inverse. So let's go ahead and do that. The first step is going to be to find the determinant of A, which again, we take this main diagonal, multiply those two entries, so 5 times 3, and we're going to subtract the product of those two entries, 4 times 2. So we have 15 minus 8 is going to be 7. So the determinant of A is 7, it's not 0, so we know we can go to step 2. Now step 2, we're going to just switch the numbers on the main diagonal. That was, we go back to the previous slide, we can see that's what we did. A goes into the D position, D goes into the A position. So when we go ahead and do that, it's gonna, the 2 and 4 at this point are gonna stay the same. And then I'm just gonna reverse the A and D elements in this matrix. So we'll call that switch entries on main diagonal. Step 3, I'm going to just start with this matrix that I started to move around. That's what I've copied here. And then the second step, or sorry, step 3 is going to be to change the signs along the other diagonal. So I'm going to keep the 3 and 5 at this point, and then I'm going to keep the 2 there, but I'm going to switch the sign, keep the 4 there, switch the sign. And we're going to call this change signs on other diagonal. So let's go back and look at our formula here. So now we've created this new matrix here, D, A, we've reversed the signs of C and B. Now we just have to multiply through here by 1 over the determinant. So that's a scalar multiplication operation. So that's our last step here, is multiply by 1 over the determinant of A. So if we do that, we have determinant A, we have from over here, number 7, or it's the 7. And then we're going to just take this jumbled up matrix that we created, where we did all the required operations. Oops. Sorry about that. Okay, that entry should be -4 there. And then we can rewrite that if we wanted to. You could leave it like that, or we could just go ahead and multiply through by that scalar, and then we'd have a matrix with fractional elements here. So I'm just distributing the 1/7 to all the entries. That's how we do scalar multiplication of a matrix. -2/7 and 5/7. And that's going to equal our A inverse. Now the second part of this, which I'm not going to go through because you can go ahead and just verify that on your own, but we can go ahead and actually check that A times A inverse, if we've done everything correctly, should give us the matrix form of 1, or the identity matrix. And in this case, since it's 2 by 2, when we multiply those two together, we should go ahead and get that answer. And then we know for sure we found the inverse correctly. So what I want to do next is just show you how you would do this on technologies. Okay, so I have the TI pulled up here. And again, to find the inverse, it's going to be pretty simple. We're just going to input the actual matrix into our calculator. 5, 4, 3, 2. And then to do the inverse, we're going to think of that as raising it to the -1 power. So that's what the notation is. And so that's how you tell the TI that you want to take the inverse. So I'm going to take the up arrow raised to the -1 power, and that means take the inverse. I'm just going to hit enter, and we can, looks like I just punched it in wrong. Let's try that again. 5, 4, 2, 3 raised to the -1. And there we go. There's our inverse. 3/7, -4/7, -2/7, 5/7. We could also use that trick where we go ahead and store the matrix into a variable name. So if I did that, I would just type in that same matrix, and then to store it, I'm going to hit Control and then the var key, which you can see says store. And I'm just going to pick a variable name. We'll pick A. Now that matrix is in the letter A. So if I wanted to find the inverse, I could do A raised to the -1, and it would tell me that. And this won't be too interesting, but if I wanted to, I could just say, what's A times A inverse? And we know that that should give us the identity matrix, and in fact, it does. So we'll just come back here and again review the 4 steps for finding the inverse. First, find that determinant to make sure it exists. If the determinant is 0, then we need to stop and just decide we can't find the inverse. And then step 2 and 3 here are just the operations on the matrix elements themselves. We switch the numbers on the main diagonal, that's step 2. We change the signs of the numbers on the other diagonal. And then the final step here is to multiply through by 1 over the determinant to get our final answer.